Hi, welcome back. So in this short video, I will talk about RAM versus CPU. So I have been talking previously when we were talking about different compute nodes, and I was stressing about that how different compute nodes may be differing in how much RAM and CPU they might be having as a resource on individual compute nodes. So in this one, I will try to give you a basically an you can say sort of like analogy based understanding what each one of them and what role do they play. So first, I'll go and give you a little bit like technical definitions for each one of those ones. So bear with me, and then I will basically explain what they are by using certain analogies. So CPU is essentially your central processing unit, and that's where the most of your calculations are happening. So when you submit a particular analysis, so you may have logics and might be any kind of calculation that are happening in that particular script. All those are being getting executed is on your CPU. So CPU is the, you can say, in terms of the main processing center of your script is. RAM is referred as random access memory, and the purpose of the RAM is essentially to store the instructions, and the stores a chunk of data or the whole data while it's getting executed on the CPU. Anytime a CPU would like to access a memory or basically place to store some amount of data while it is doing its computation, it uses the RAM. So RAM is the, you can say, the quickest access in terms of data storage for a CPU is. You can read more definitions on Google or anywhere else. You can search more about them, what they actually does. But if I want to explain this one by an analogy, I will say that let's say you think about we have a problem of a jigsaw puzzle, and what we want to get is the final solution. Now, what size of jigsaw puzzle? What's the size of the jigsaw puzzle we can solve? And basically how quickly we can solve. Those are the two concepts, or basically the two. If we are in a competition, that's what we're looking for. What's the size and how quickly we can do it? So if you're looking on the right hand side, that's the analogy. So the surface area of the table will pretty much determines what the size of the problem we can solve. So the bigger the size of the table, the larger the problem we can solve, or the larger the big jigsaw puzzle we can solve. And that's pretty much equivalent to the RAM. And the number of individuals who are working on assembling this particular jigsaw puzzle, you can think them as CPUs. Those are the workers. So they can do individual assembly in different corners of a problem, and then can bring it together to get the final solution. So that in a way, you can think of them, these are actually working in parallel on the chunks of your data, the CPU. And finally, what they do is bringing it together to get you the final solution. That's how big a problem you can solve depends pretty much only what's the surface area of the table is. So that's where the RAM and CPU can think in terms of an analogy. So hopefully now you have some idea, and this is not really, you can say 100%, but I think just a vague, you can say basic idea about what a RAM does and what a CPU does. So in the next video, we'll try to get connected to the Xanadu cluster and go from there.